Okay, so this lesson we're going to continue our talk about transformations. Remember that if we have the transformations that we talked about in the previous lesson, the resulting shape is going to be congruent or the same shape and size as the original shape was. Well, this lesson we're going to talk about similarity transformations that still have the same shape, but they're going to be a different size. They're either going to be larger or they're going to be smaller. Okay, so those are called dilations. All right, and a dilation that is has a scale factor greater than 1 is going to be an enlargement, or if it's multiplied by a number between 0 and 1, okay, then it's going to be a reduction. All right, so and you find that dilation by multiplying both the x and the y coordinate by the same number. All right, either a number bigger than 1 or a number between 0 and 1, which would actually be a fraction. The only thing that we're talking about is that that number cannot be -1, because if we multiply both the x and the y by -1, that is a congruence transformation of a rotation of 180 degrees. Okay, so this right here are the same tables and stuff that you copied into your notes last week. Last lesson. So if you have those in your notes, you don't have to copy them down again. If you did not copy them into your notes last lesson, go ahead and copy these into your notes as well. All right, so what is a transformation, and is the resulting figure congruent or similar? Okay, so if I look at the ordered pairs, well, the 2 and the 2 are the same, but -2 turns into 1. Okay, so we're talking about this right here. All right. Once again, the 2 and the 2 are the same. 3 goes to 6. All right. 3 goes to 6 again here. The y's stay the same. And -2 to 1. So if we look at what we have there, this is the same thing as +3 to the x, +3 to the x. So we're adding 3. We're adding 3 to all of the to each of the x terms. Okay, so if we look at our notes from the previous lesson, we said that if you add 3 to the x coordinate, that means that, and the y coordinate stays the same, that means that we are translating or translating to the right. So it's a translation right 3 spaces or spots. Okay. All right. So that's a translation to the right 3 spaces, and it's going to be congruent. Okay, because the size didn't change because the y coordinate did not change at all. Okay. Here, what's this transformation? Well, let's see here. This stays the same, the y stays the same, y stays the same, y stays the same, and y stays the same. The -1 turns to a +1. Same with point B and B prime. -3 turns to a +3. Okay, so if we look at what we did here, we know that we multiplied both the x value by -1. Okay, and so we did that we did that with all four of the points there, that we multiplied everything by -1. All right. So if we multiply the x by -1, that means that if we're looking at our notes from the previous lesson, that means it is a reflection. It's a reflection across the y-axis. And by the way, the y's here stay the same, so the resulting figure is congruent. Okay? Here, let's see what we did. Well, if we look here, -1 turns to -2 and 3 turns to 6. So we have both the x and the y that change. All right. This turns to a positive, stays from a negative to a negative and a positive to a positive. So the signs on all of these don't change. The only thing that we did is we multiplied both the x by 2, the x and the y by 2. 3 times 2 is 6. -1 times 2 is -2. -2 times 2 is -4. 1 times 2 is 2. -3 times 2 is 6. And 2 times 2 is 4. So we multiplied by 2. And so that is an enlargement by a scale factor of 2. All right. Well, let's look what we got here. Well, let's see here. So we went from 1 to -1, 1 to -1, -4 to 0, 0, -4 to -4, 0 to 0, 4 to -4, -2 times turns to +2. So here we multiplied by -1, both the x and the y. Multiply both the x and the y by -1. So if we look at the notes from last week, or not last week, but last lesson, that is a rotation of 180 degrees. So we rotate 180 degrees on that one. All right, so -6 to -5, 0 to 1. -5 to -4, 2 to 3. -2 to -1, 1 to 2. -2 to -1, -1 to 0. And -5 to -4, and -2 to -1. So we add 1 to both x and y. So we really hadn't, let's see here, we really hadn't talked about that, but this is a multiple. This is a multiple translation, or a multiple translation. And what we did in this case, we went from the x, we went from -6 to -5, so that's adding 1. So we moved right 1 and up 1 because the y was increased by 1. Okay? And it looks like this is congruent. Okay? Because when we do that addition, it just the coordinates stay the same. Okay? All right, so -5 to 4, -5 to -5, 4 turns into -4, -1 to -1, 3 turns into -3, -4 to -4, 1 turns to -1. So we multiply the y by -1, which if we do that, that is a reflection across the x-axis because we changed the y value, change the sign of the y value. Okay, and it's going to be congruent. Okay, oops. All right, and let's see here. Another one. What's the transformation? And okay, so what we got here, 1 and 4 turns to 4 and -1. 3 and 6 turns to 6 and -3. Okay, so this is what changed. This is what changed sign. Okay, and they flip-flopped. They flip-flopped the x and the y coordinates, which leads us to suspect that it's a rotation. So if the rotation that says that you multiply each x coordinator by -1, then switch the x and the y coordinates, is a 90-degree clockwise rotation. All right, and once again, they stay congruent. All right, and then the last slide. Well, here again, this is just a graph, so that's pretty easy. What we did here is we just simply reflected across the x-axis. All right, so this goes from 1 above to 1 below. This goes from 2 above to 2 below. This goes from 1, 2, 3, 4 above to 4 below. So this is a reflection across the x-axis. Okay, and it's congruent. It stays congruent because it's the same size. So anyway, make sure you copy those rules down if you haven't already done that. Make sure you copy that first page of notes down with the definitions, and make sure you ask questions if you didn't understand something. And we will talk to y'all later.